Welcome to Unit 1, Lesson 6 review. Today, I'm going to use a notebook software to demonstrate adding and subtracting mixed numbers. I can use equivalent fractions to add and subtract fractions by adding and subtracting mixed numbers with like denominators. All right. You might just discover that it's really not any different than adding and subtracting whole numbers or adding and subtracting fractions. It's just kind of a combination of them. Let's say we have this math situation. Celso swam 1 2/3 lengths of the pool this morning and 1 2/3 lengths of the pool this afternoon. How many lengths did he swim today? If you're not comfortable on how to say these mixed numbers, I suggest you view lesson 5. So, I would start with a diagram. Let me see here. So he swam 1 2/3 this morning. 1 2/3 this morning. And 1 2/3 lengths of the pool this afternoon. So 1 2/3 lengths this afternoon. 1 and 2. And that's about as good a drawing as I can make with my mouse pad. So, how many lengths did he swim today? So that would be all that. So that tells me, hey, I'm going to add and find the sum. 1 2/3 plus 1 2/3. Now, if I was with you, I would just have you add those two and explain how you did it. And then we would discuss the different methods that should have come up. But since I'm not with you and able to do that, I'm going to show you the different methods that you may have chose. One is to draw a diagram just like I have. 1 2/3 plus 1 2/3, shade in, shade in. So when I do this, I see I have one hole and another hole, and I could come here and say, there is one more hole. So now I have one hole plus this one plus one more hole this one plus one more hole this one. Plus I have this right here, which is 1/3. So now what is that? Well, I can add my holes. 1 plus 1 plus 1 is 3. And then add my fraction parts I have left. 1/3, 3, and 1/3. Another way a student might do it would be add the whole number parts and fraction parts separately and then regroup. Say, hey, 1 2/3 plus 1 2/3 can be decomposed. 1 2/3 could be 1 plus, plus 2/3 And this 1 and 2, and I have to add it to this 1 and 2/3 could be decomposed to 1 plus 2/3. Whoopsie. So that is not 2/3, Mr. Springer. So what I can do is add my whole numbers, 1 plus 1, add my fractions, 2/3 plus 2/3, then add them together. 1 plus 1 is 2. 2/3 plus 2/3 are 4/3. And now add those together. And that gives me 2 and 4/3. Now I should notice when adding, what can happen is I can ungroup 3 of these thirds to give myself one more whole. So 2 and 4/3, well, is 2 plus 3/3 plus 1/3, because 4/3 is 3/3 plus 1/3. And now add that. 3/3 is 1 whole to my 2, gives me 3 and 1/3. Now I would do most of this work in my head. I would just say, hey, I can add the 1 and the 1 is 2. 2/3 and 2/3 are 4/3. 4/3, I can regroup 3/3 to give myself one more whole. One more whole than 2 is 3, and I have 1/3 left. So that's how I would more do it in my head. But this was showing my thinking. Taking a look at doing it vertically. When I get to larger, more difficult numbers, I probably more so do them vertically. Add my wholes. 1 whole plus 1 whole is 2 wholes. Add my fraction parts. 2/3 plus 2/3 is 4/3. Then I would think in my head, hey, I can ungroup 1 whole. And 2/3 plus 2/3 is going to be less than 2 wholes because it's less than 1 plus 1. So it's either going to be a fraction or a fraction greater than 1, but not greater than 2. So I'm going to take out 1 whole, which would be 3 of the thirds, and add that to my 2 wholes to give me 3 wholes. And after I take the 3/3 out or group those 3/3 into a whole, I have 1/3 left. Now, there is a third way that can work also, is to rewrite the mixed numbers as fractions and then add. I can change 1 and 2/3 into a fraction greater than 1. 1 whole is 3/3 plus the other 2/3 means 1 and 2/3 is 3/3 plus 2/3 or 5/3. If you remember, we learned a quicker way to do that is say 1 whole multiplied by 3 is 3/3 plus the other 2, 3/3 plus the 2 we already had, make 5/3. And now add those, gives me 10/3. And here's the reason why I don't like this method is when we have bigger numbers, these can get really big. Now I have to also convert this back into a mixed number. Remember, every 3/3 is a whole, so I want to know how many 3's are in 10. That means divide. My numerator 10 divided by my denominator, because every 3/3 make a whole. There are 3 3s in 10. 3 multiplied by 3 is 9. And when I subtract, I have 1 left. That 1 was part of my 10, which was my numerator, and the size of the pieces were thirds. So I have 1/3 left. 3 1/3. So all these methods work for adding mixed numbers. You can rewatch my video and then practice using the ones that you and figuring out what you're most comfortable with. I'm going to show you quickly, just if you want to do this page, here's a look at the problems, you can do them, or I'm just going to show you a couple of them quick. When I'm doing this, I would add, you could rewrite them, or I could just do a lot of them. 4 plus 2 gives me 6. 1/9 plus 1/9 are 2/9. 2/9 is less than 1 whole. I have the mixed numbers 6 and 2/9. 5 plus 2 equals 7. 3/8 plus 2/8 are 5/8. 5/8 is less than 1. I have the mixed numbers 7 and 5/8. 1 1/6 plus 3 4/6. 1 1/6. 1 plus the 3 gives me 4. 1/6 plus 4/6 gives me 5/6. My numerator 5 is less than my denominator 6, so my fraction is less than 1. 4 and 5/6. 4 plus 6 is 10. 1/3 plus 1/3 are 2/3. 2/3 is less than 1. 10 and 2/3 is fine. 2 1/4 plus 2 3/4. 2 plus 2 is 4. 1/4 plus 3 more fourths are 4/4. Okay. 4 is not greater than 4. It's equal to 4. 4/4 equals 1 whole. So I can group 4/4 as one more whole and add it to my 4 gives me 5. And I don't have any fourths left, so it's just 5. 3 2/7 plus 2 5/7. 3 plus 2 is 5. 2/7 plus 5/7 is 7/7. Again, when my numerator and denominator are the same, that equals 1 whole. So I can group 7/7 is one more whole. Add it to the 5 I already have. Gives me 6 wholes and no 7s, so just plain 6. 1 3/5 plus 2 4/5. 1 plus 2 is 3. 3/5 plus 4/5 are 7/5. I notice 7 is greater than 5, so I know I can take a whole out. I know that 3/5 plus 4/5 is less than 1 plus 1, so it's less than 2. I can only take one whole out. I'm going to group 5/5 to give myself one more whole. 1 more than 3 wholes are 4 wholes. After I grouped 5 of the fifths, I have 2/5 left. Now, since this is the first one in a while I've had to do that, let me show you why that worked. 3 7/5 is equal to 3 plus 5/5 plus 2/5. 5/5 is equal to 1. So it's the same as going 3 plus 1 plus 2/5. 3 plus 1 is 4, plus 2/5 are 2/5. That's all that I was doing just in my head. I regrouped 5 of these fifths as one more whole and added it to the 3 and took the 5/5 away from the 7/5 to have 2/5 left. 40 plus 22 equals 62. 6 sevenths plus 5 more sevenths are 11 sevenths. Okay, I notice that I can group 7 sevenths to make a whole. Sometimes I have students do this. They're going to subtract 7 sevenths for a whole, leaves them with 4 sevenths. And these 7 sevenths they took away, they're going to add to their 62 wholes to make 63 wholes. 62 and 11 sevenths is equal to 63 and 4 sevenths. 6 plus 4 equals 10. 8 ninths plus 7 ninths, I'm going to add my numerators. 8 and 7 are 15. And keep my denominator the same because the size pieces didn't change. Now, I know that I can take and group 9 ninths. So I'm going to take out 9 of these ninths to give myself one more whole. So 10 plus one more whole makes 11. 15 ninths, take away the 9 ninths, leave me with 6 ninths. Some of you might notice 6 ninths can be simplified. 6 and 9 can both be divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So if I wanted to write this in simplest form, I could rewrite it as 11 and 2/3. So that is adding mixed numbers. Really, to me, the only tricky part is when you have to ungroup one more whole. Now to subtraction. I have 3/5 yards of string. I cut off 2, I have 3 and 5/6. I did not read that right. I have 3 and 5/6 yards of string. I cut off 2 and 1/6 yards for my sister. How much string do I have left? So let me see here. My string, they told me my whole that I have are, see if I can say it right, 3 and 5/6. If I cut off 2 and 1/6, how much string do I have left? Well, if I had 3 yards and I cut off 2 yards, I would take 3, subtract 2 to find out how much I have left. So I'm going to take 3 and 5/6, my whole, and subtract the part I cut off, 2 and 1/6, to see how much it equals. So there's my equation. Okay, just wanted to check and see if they showed it to us. All right, so how am I going to do this? There's lots of methods. You can give yours a try. I like to subtract my fraction parts first. Just like when I do other subtraction, I usually start with my least place value. 1/6 taking away from 5/6. 5/6 subtract 1/6 leaves me with 4/6. 3, now my whole numbers. 3 subtract 2 is 1. 1 and 4/6. I notice 4 and 6 can both be divided by 2. So I'm going to divide them. To simplify, I divide by 1 and form of the fraction 2/2. Gives me 2/3. So 1 and 4/6. 4/6 is equal to 2/3. I get 1 and 2/3. Now, that worked pretty nice, but I remember with subtraction, sometimes I don't have enough. I had enough 6 to take away, but sometimes I don't and I have to ungroup. Let's see how we handle that. All right, so there's a couple ways you can ungroup. 7 and 1/5 subtract 2 and 4/5. Actually, what I think I'm going to do is, let's see here. It doesn't let me really see it very well. All right. So what are they doing here? Let's take a look at it. All right. So what's going on here is they are saying, hey, when I'm subtracting 2 and 4/5, to take 4/5 from 1/5, I would go into the negative fifths. Don't usually want to go into the negatives. Where am I going to get some fifths from? I'm going to get some fifths from my whole. So if I ungroup one of my whole, I now have 6 wholes. That one whole is going to give me how many fifths? Well, 5/5 are a whole. And I had another 1/5 right here. So what I did is change 7 and 1/5 to 6 plus 5/5 plus 1/5. Because 7 is equal to 6 plus 1 in the form of the fraction 5/5. And then I had one more fifth. Well, what is that altogether? That's 6 and 6/5. Now I have enough fifths to take 4 away. 6/5 subtract 4/5 are 2/5. 6 subtract 2 is 4. Now here they're showing you is you can do this vertically right here. 7 and 1/5. Ungroup one of my wholes. So now I have 6 wholes. It gives me 5 more fifths. 5 plus 1 gives me 6/5. 6/5 subtract 4/5 are 2/5. 6 subtract 2 is 4. Let's try another one. Let's say I have 8 and 3/7. And I'm supposed to subtract 2 and 5/7. Now, I know that if I took 5/7 from 3/7, I would have a negative 2/7. Don't want to do that. I need some more 7s to subtract from. So I'm just going to come up here and take one of the 8 and ungroup it. So now that 1 is gone, and it is 7, it's going to give me 7 more 7s. Because 1 whole equals 7/7. And 8 equals 7 plus 1 more, or 7/7. So 7 plus 3 gives me now 10/7. A lot of times what I would do with students is I would give them a whole bunch of fractions like this and have them ungroup one, or mixed numbers like this and have them ungroup one. Ungrouping one gives you whatever your denominator is of those. So now I have 7 and 10 sevenths, subtract 2 and 5 sevenths. 10 sevenths subtract 5 sevenths are 5 sevenths. 7 subtract 2 is 5. Now, when we do number talks, a lot of times realize that when subtracting, you can count up. I have 7 and 1/5 subtract 2 and 4/5. I can count up, because all it is in subtraction is finding the difference. I can count up from 2 and 4/5. First, go to the next whole number. How much do I have to go up to go from 2 and 4/5 to 3? Well, I have to go up 4/5. I had to add 4/5. Now, to go from 3 to 7, I have to add 4 more. So now I've gone from 2 and 4/5. Think of myself on a number line. I'm starting at 2 and 4/5. I went up 1/5. Actually, let's put it under here. I went up 1/5 to 3. I went up to 7, which was going up 4. And now I'm going to go up to 7 and 1/5 is going up 1/5 more. So going from 7 to 7 and 1/5 is going up 1/5. So 4/5 plus 4 plus 1/5 is 4 and 5/5. Wait, my bad. I see the mistake I made. I'm so sorry. Where's my eraser? I'm like, that doesn't make sense. There's my eraser. This is not 4/5. 2 and 4/5 to go up to 3 is going up 1/5. There, I have it right up here. I don't know why I did it wrong down here. Sorry about that. I went up 1/5. So 4/5 plus 1/5 plus 1/5 is 4 and 2/5. 4 and 1/2. So that is a way to count up. A final way that some students do it is they convert both numbers to fractions before subtracting. Now, if you look, I end up having some pretty big numbers. All right. How do we do this? They had 7 and 1/5 subtract 2 and 4/5. Well, I'm going to use the most efficient way for me. 7 wholes multiplied by 5 would be 35/5. Plus 1 more fifth that I already had gives me 36/5. 2 wholes multiplied by 5/5 for each whole would give me 10 more fifths. Plus the 4 I already had give me 14/5. Now, that I have common denominators, I can just subtract numerators. 36 subtract 14 is 22. The sides are fifths. So 22 fifths, I can now change into a mixed number by saying every 5 of these 22 is 1 whole. So how many 5s are in 22? 4. 4 groups of 5 are 20. And I still have 2 left. Those 2 are what's left of my numerator, 22. And the size of those pieces are what my divisor was, fifths. So that's how they got 4 and 2 fifths. As you can see, it can be cumbersome though. There's some big numbers to use and it's an extra step. All right. I suggest reviewing this video for the method that works best for you. When I can do mental math, I don't mind using this method, but ungrouping is usually what I would do, especially until I get familiar with it. Good luck.